All right, now to introduce our next speaker. She has been a close friend for a few years. We actually met long ago when we were working at a company called d1g.com. She's a DevOps engineer. She moved on to work with other companies such as Freesoft, Blue Kangaroo, which is a company that had offices in the US and Jordan. Barclays Bank, she was part of the DevOps, she was actually a team lead at the DevOps department in the security security team. And now she's a DevOps lead at Expedia in UK. Dina Abu Khader is a real example of someone who I think has been working on herself, working on improving her skills, and growing up the ladders of companies and as a person as well. So I think there's a lot we can learn from her. Very proud to have her here with us. Please welcome Dina Abu Khader.
Hello, everyone. Oh, it's hi. Okay. I guess Fuad did the whole introduction. I'm a DevOps engineer working now in Expedia, and today I'm going to take you on a journey to understand what resiliency means and what chaos engineering as well. So let's start quickly. Oh. How does... Okay, yeah. So we know that we all had previously the monolithic infrastructure, and everyone now, we were just talking in the previous presentation about moving to microservices. And this is like how the structure for that, we used to have single database and one backend, and now we are moving toward to have multiple databases and multiple applications that serve our clients. Okay, so why we moved to microservices, as most of us know, is easy to understand, is easy to scale, easy to rewrite if you want to move from Postgres to Mongo or from Mongo to Postgres, and freedom as well to deploy within the infrastructure of our departments and organizations. But what will happen after we have a mid-size organization like Expedia or Google or Facebook, or even like mid-size of startups? We will have multiple and hundreds of endpoints within our core system. And this is very hard for a DevOps engineer to understand and know what's happening, how the calls are going around, and so on. So this is one of the pictures that describe one of the endpoints in the organizations. So I guess you guys know this famous quote? Yeah, so anyway, Facebook, I don't think now they can move fast and break things because they had like security breach and data breach in the last 12 months. One question I want to ask the audience here, do you know why your system break? Do you have like statistics? What's the major cause of the problems? Is it only release? Hmm? Okay, so statistically, within multiple organizations, most of the outage we had are related to certificates, SSL. We have on one point, SSL certificate, that's been there for 3 years. After 3 years it expired. We don't have a good documentation, for example. No one knows about it, and it's break. And we have an outage. And until you understand where is this SSL certificate is there, you've lost like 3 hours of your business. And it costs you like a few millions sometimes. It depends on your application and your service. So a lot of small stuff can break your application, and sometimes their network. I remember one of the outages I had while working with one of the startups. We had a loose wire on one of the server as a hardware. And until we figured out and replaced that wire, we had a few outages that caused the company a lot of money. So a lot of these outages are sometimes related, as I said, SSL, network, sometimes code, and sometimes as well Facebook login and Google APIs that as well can destroy or like make a big outage on your services. So we want to make our application more resilient. And why resilient mean? We go to this picture, which means I'm going to break my stuff are going to break, but I want to be able to bring them back to steady state and make them working and retrieve the status of my application to serve my clients. And this is Google translation. If you go say what defined resilience, this is what it comes. And it means that I can be able to retrieve my service as fast as possible. And how to become better at resiliency is like we have to decrease, as I said before, the time to restore the service. Like if I have Postgres database has been completely destroyed, I need to have the good tools, the services to restore it, be able to have a backup and restore the service. Frequency of production deployment is like have multiple production deployment per day, and once I undefined as well, the lead time here means once I undefined a problem on production, how long it will take me and my team to start working on this bug to put it on production. And the more we decrease these times, the more resilient my application is. Decrease the change failure rate. So if I have team X works on like flights application, like in Expedia or whatever your endpoint is, and whenever they have a release, we have a big outage. So we need to understand why, we need to understand what's the review code within their application and so on, and then try to decrease this failure rates because it's affecting us. And as well, the major topic of our presentation today is adoption of chaos engineering within our system. Does anyone know what is the concept of it? Okay. So it's a new concept. This is one of the stuff. So it's breaking things. Who likes to do rm minus rf slash on the servers? Oh wow. Okay. So this is one of the instance you can do that, and the company will reward you and tell you thank you for doing this. We discovered when we destroy one instance, this is what's happening within my application. So this idea started in Netflix in 2010 when they were starting to move their infrastructure from data centers to AWS. And as everyone knows who works in DevOps or application side, we know that hardwares are not up 100%, right? We will have problems. So they want to understand what will happen if one rack of AWS goes down. How my users are going to receive my streaming applications or like service. Am I going to lose my customers? Is it going to affect my business model and so on? And in 2011, they start to inject failures within their service, of course on a small radius or geolocation, and then the idea started to evolve more and more, and in 2012, Netflix has opened it to the world, and they start to have chaos engineering positions and leads. And in 2014, part of their team have moved on, and with other companies like Salesforce and so on, they combined and they start something called Gremlin. Who knows Gremlin here? Okay, perfect. So as well, Gremlin is the concept of adding failures within, inject failures within testing. Like I want to destroy, I want to have 100% of my memory to be consumed on the server or CPU, or I want to consume the whole bandwidth on this instance or this rack. And I want to understand how my application is going to behave. Is it going to give me time out? Is it going to serve my customer? Is it going to fall over to the other region if I have high availability setup and so on? And this is one of the stuff that I guess when we have a medium-sized organization or like financial sectors, this is very important to understand these stuff because I guess everyone hates when they are called on Friday or Saturday to fix stuff. So the principle of a chaos engineering, they're very easy. Plan your experiment, and I'm going to explain in details now in this presentation how to plan these experiments, contain the radius, like say I want to test it on this endpoint or on this location and so on, and then depends on the result, you scale, you make it bigger or you squish, and then because if it's broken or you want to understand and debug. So the teams that needs to be start using that, and I highly recommend to start from this week, is the people who works with data, and we understand how data is very precious in our industry at the moment, and was like one of them is like the data scientist and so on. So the data is very important, and we can't afford losing data. So streaming, storage, databases, and data teams are the people who should start trying to implement these concepts within their present organization. Who has this manager who bought Hadoop, he bought data scientist team? No, okay. So when we buy Hadoop in any organization, they think, oh, now we have data scientist team, we're going to have everything is going to work, we don't have latency, the network is secure, it's working 100%, and we don't need more than one administrator because it's already distributed system, and so on. But this is wrong, and as I said before, going to the network level and the hardware level, sometimes it's become very messy. So the people who know me, I'm a very random person, so we're going to do a bit of detour of the presentation now. Who knows Elasticsearch? Woo! Okay, so this is the basic setup for Elasticsearch that we're going to use now in our example. I just want to make sure that everyone understands. We have an installation of masters that are the brain of the cluster, the data nodes who are where we storage the data, and then we have the client that interface with the application or the API. Data is distributed on the nodes by primary and by shards, which means the data can go to shard 1 or shard 2, and we have replica of each shard, and then the primary and the replica of one, they don't go on the same physical machine. So this is for distribution and high availability if we lose one node. So now, I believe everyone has high availability on two different regions in AWS. So let's assume this is East 1 and this is East 2, and this is my storage for logs, for example, or like for cybersecurity or whatever. And I have this high availability setup, and I want to test by chaos engineering methods how my application is going to behave. So just to recap here, we have 4 types of experiments. So we're going to start with experiment number 1, which is known of the known. So let's assume by chaos engineering concept, I drop one of the master nodes. And because the master node is the brain, but I have replica of it of 3, I assume my cluster will work fine. Nothing will happen. The calls will continue coming and going up, and the write and the read will be fine. No timeouts, maybe it will be added by 2 milliseconds or 3 milliseconds, but this is what will happen. And hopefully my calls won't fall to my standby setup. But what will happen if I have this structure on AWS? What should happen? Okay, by auto-scaling, as code deploy and so on, I should have the instance should come back without me getting involved, should be reconnected to the cluster, and should work fine. And because it doesn't have data, there is no shifting with the data. So this is experiment number 1, like one of the concepts that you can do within your organization. Another one is, if I drop one of the data nodes, what will happen? Is it like as well, I need to answer this question, and every application and every setup is different. So you need to do these experiments within your organization to understand how your application is going to behave. And as well, with auto-scaling, code deploy or whatever Terraform that you're using or whatever application you're using for infrastructure, it should come back, add it to the cluster, and the data should shuffle. So this is experiment number 1. It's the normal level 1, which means I'm going to test the things I know and how they're going to behave. So we're going now to experiment number 2, the known of the unknowns, which means I know that data node came back, but I don't know how long it takes to rebalance the data on my nodes. I don't know how long does it refull. Did I lose some data? The data that was in the buffer writing on this node? Did I get enough alerts? And this is more about the timing. Collect all the timing within your organization to understand what's happening, because as well, we don't need to understand what's happening with our storages once we have the outage. So now we're getting to level 2 of difficulties, which is we're going to say, if I drop few data nodes, like 3 or 4, what's going to happen? And this is a big possibility that I'm going to destroy a whole shard here. So of course, again, with auto-scaling, blah, 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 it's going to come back. But I don't know what's going to happen. Is my clusters behaving correctly? Do I have timeout? Does it go to red status? Did it fall to the other region? Do I have automatic fall over to the other region, and so on? And these are the questions and the plan of the experiment. And of course, we try to test this stuff on test, not production. But we have to understand, and these are the concepts. It depends if you have MySQL, Postgres, it's going to be a bit different. Unknown of the unknown. If we have a whole region of AWS for some reason, like aliens or something, it came to the data center and it stopped all the connection from it. What's going to happen? Who has an automatic failover on clusters here? Okay. So what will happen is everything will come back, but I don't know what will happen. And this is why it's known the unknown of the unknown. And we can't understand what will happen until we test it, we collect data, matrix, a CPU, latency, throughput, and so on. So this is the 4th type. And now we're going to move to how we are going to adopt chaos engineering within our organization. I know it's a bit like scary to destroy a whole cluster maybe, or instance, especially the data nodes instance, because we don't know. But I'm going to start with the baby steps with you guys, how to start adopting chaos engineering within your organization. So the first step, which is the basic one, is start to reboot your servers. Let's start on test. Make sure that there's no developer has any manual changes or manual run services on the servers. And this makes the habit of everyone to put everything in the source control. So every week we can go and reboot the whole servers, of course in sequence, maybe not at once, and see how everything's work. Number 2, which is rebuild your application stack once in a week, depends on your release. The more automation we have, the better we become. We understand dependencies, we understand if I'm missing something, if someone tweaks something manually on the servers or the application or the code as well. And this gives us more, what they call it, confidence in our application when we have disasters. So if you have a disaster, you can say, drop this cluster, I'm creating a new one from scratch. And this is how you become more resilient in your organization, because resilient means you're going to break stuff, but you have to become stronger when you come back. Number 3, start to inject latency. It means that I depend on Facebook login in my application. Most of us does. So I want to understand if Facebook logins go down, how my application is going to react. And of course, we can't go to say to Facebook, please stop accepting calls from me. So we're going to inject some latency on that. In the TCP layer, we can inject some latency to the calls or endpoints. And we can as well try, which is a very good point, which is restart your application with the endpoints. while the endpoints are not available, which means we can redirect these endpoints to the local host, restart my application, see how my application reacts. Does it start? Does it fail? And so on. And now we can alternate between two standby environment, like green and blue. Everyone heard about green-blue setup? No? Okay. Faisal is saying no. So, I guess, which means that we have two identical environment, on the same release, same setup, but which each release or each disaster recovery, or like when we have outages, we move only from the router, we move the traffic from one environment to another. And it's a good practice because most of us, and I guess I witnessed that when we have a disaster recovery cluster, we don't take care of it. We leave it there until like we have certain outages and we start trying to fix it to start taking traffic. And this is bad practice. The good practice is every week we alternate the traffic between the two clusters just to make sure that we are giving the two clusters the same amount of care. So, as well, what we are going to do next now is we want to start writing end-to-end tests. I work in Expedia. Expedia is a travel agency that serves different types of services like flight, which is air, hotels, trains, and activities. So I want to understand why my users come to my site. Maybe they do search of flights. So the user journey for them, they go to the site, they put destination and look and start point, and they do the search. So this is, we call it a user's journey. And when they got to the service search results, this is maybe point 3 in the user journey of my maybe 20% or 30% of my traffic, and then they continue to the checkout. So from A to Z, this is a user journey. And once I have this user journey documented somewhere from the QA or like business product managers, I take this user journey and try to produce it automatically. And as well, I try to do with the previous experiment, like drop one master node, drop one data node, and so on. And I see how my user journey test behave. And this is very important to relate the two tests and the experiment together, because it's help you to understand what the user will see when we have an outages. Choose your ends wisely, which means, as I said, we will have thousands of endpoints. Maybe we want only to start testing the endpoints that are has more calls on my website, not the ones that have 10, because if I have endpoints that is called 10 times, maybe it's fine if it's break for like 1 hour or 2. But if I have a call that is called like 100,000 times per millisecond or per second, I need to understand how my application is going to behave. And of course, as I said before, automate everything, especially the infrastructure side. I know it's a pain and it will take a lot of time, but it's good to give the team like 3 months of time to deliver these things for you. And as we said before as well, the data is very precious. So we have to understand how my data is stored, how my data is acted as well around, together, and how to make these tests. So your homework for tomorrow, which is the Sunday, is talk to your manager, after you have your coffee, of course, and say, I want to start doing a test, I hope, and say I want to drop one of the slaves of Postgres or the secondary of Mongo, or I want to see my application, how it's going to work on test, and see. And if you don't have automation, start to put it in the roadmap and say, I have this thesis will have in my test that if I drop a master node, for example, nothing will happen. My application will work fine. And convince your manager, do it, check your results, write it down, document them, And if you, of course, if you break things, make sure that you have a role plan within your test, fix it and repeat. And I guess this is very easy to start with tomorrow, hopefully. And I guess I have 10 minutes for questions. Whew.
So much. Great job. Okay, so I guess first order of business, if your server goes on fire, is to turn it off and back on again.
Yeah.
I'm sure in the UK, a lot of people call you up and say, oh, have you tried to turn it back off again? Okay, do we have any questions?
Yeah.
Yes, we have one question right here. And then we'll go to the back. Yes, go ahead, Tambi.
Hi, Dina.
Yeah.
Thank you for the amazing talk. I wanted to ask, do you do chaos engineering tests like in production or not?
So the concept of it starting it with production, but if we're not mature enough, I recommend to start with tests. Make sure that you have a rollback plans and so on, and how fast you can retrieve the status. And then, of course, you can start with production on a small geolocation or a small number of users. You can collect, specify that, and then you can increase your radius. So it is for production, but of course, if you are not mature enough, you start on test.
Yeah, you can do it slowly. And just to follow up with another question, what do you think about actually doing it without telling anyone? So do people do that?
Telling one management or users?
Like just going and pulling the
plug.
wire.
Pulling the plug.
Yeah. I guess it depends on your business, right? If you're going to lose millions, you have to tell your board. And one of the notes that I once heard in Google Talks, that Google and Facebook, they have a budget for failure. Like outages failure, they call it. They go and encourage their employees to, they have like this budget, you are able to lose this money on production, just break things. And once they break it as well, the developer who break things take a big bonus, because they say, thank you, you found something not good within our system. So as well, this is big companies that they can afford, they have failure budget.
Great. We have another question? We have a question in the back.
Hi, I just have more questions about the job specification. As I want to break this code, but if I like the instance deleted or something like this, we have a strategy to recovery. There is a plan for recovery. Is this also responsible for this engineer? Because there's many plans related to AWS or depend on the cloud are working on it.
Okay, so your question is it related to the planning, release planning, or failure planning?
Exactly, and the continuous of this, because many of the project and the deployment, it depends on many projects or many microservices with many teams, with many contributions. So when I do the break things, I want to do the recovery, how we can manage this and how we can plan this.
So this is how you're going to plan it. Depends on your service, right? Or your application, how it's distributed, how it's designed. So the chaos monkey, the concept came when I have a random monkey within my application that destroy different stuff on different times without me knowing. But of course, not everyone can handle this now. So it is related to document everything. As I said, like one of the best practices is to document the user journey and try to do the test within that journey, and you'll know what you're going to break at the first, and then and as I said as well, you say you put some thesis saying this is how my application is going to behave. So it's planning, and then when you become more resilient, you start doing things randomly, because this is how the world is.
Great.
So if there's a question here.
Okay.
Yeah.
Hello, thanks for the talk. I just wanted to ask, how do you manage zero downtime deployments? Is green-blue approach is the best approach?
So there's different approaches. There is black-red, if you heard about it. and there is a green blue. Green blue, it's like one of the environment are ahead one release or behind one release. There's another especially in the financial sectors. There is something called red blue, where the two environments are on the same same release number. So it depends. It depends on your application and your status, on your organization, how much you can afford. And as well, the best practice is to have blue-green, but some people have the blue on a data center and the green on AWS, and then they can increase the number of instances only if they have an outage, and so on. So it depends how much you can afford and how much team you have and how much you can develop.
Other questions? Just raise your hand. We have time for one more. All right. Well, thank you very much, Dina, for being with us.
Thank you.
Excellent job.